In the last video, we looked at the definition of modules and the creation of modules, and we had mentioned that Numpy was one of those key entry-level modules. So let's get into Numpy, and this also introduces the topic of data structures in Python. So Numpy facilitates our numerical operations, also vector matrix calculations, and in effect operates on arrays in Python. Numpy is quite a large module, and there are many variants in its use, many styles of use, and you should definitely check those out. So in this video, we are just reviewing some of the basic functionality, and we're looking at the most common use cases. It's a large topic, and you should read more around this. Of course, we have to import the Numpy module before we can start using it. And quite often you'll find that Numpy is abbreviated. It's given the alias NP. So when we use Numpy, we gain access to our transcendental functions. So here we can use our exponentiation and sines and so on. So just running those two blocks, you see you are getting results this time. So you can't perform these operations in Python core, but you gain access through Numpy. So that's one. Another one, in terms of your vectors and matrices, you can quickly fill your vector or your matrix using, for example, zeros and ones. So let's just comment this out. So you can use zeros here. This statement will require an array to be created of length 4, and for that to be filled with zeros. So if we run this, you can see all those zeros there. We can also create what's called a tuple. So a tuple of values like that will then create a 4x3 matrix of zeros. And remember, the first index is the row number, the second index is the column number. So this statement tells us to create 4 rows and 3 columns and to fill them all with zeros. We are specifying here that we want all these numbers to be integers. If we just drop that, the default is, I guess, a float. So that's how we can fill with zeros. Alternatively, we can fill with ones, and this is in general an ND array. So if we use another value in the tuple here, then you see we have an array of an array of an array. So we do have 3x2 matrices, and we have 4 of those. So it might be easier to read it from right to left. So the last 2 digits tell us that this is a matrix of that size. We read it as rows and columns, remember? And then all the digits to the left of that tells us how many matrices of matrices we have. And as we say, we can have many of these. So we can have a tuple. There's no end to a tuple. There's no restriction on how long the tuple can be, well, other than memory, of course. So anyway, that applies in general when we are using our Numpy functions. We work in terms of tuples. By the way, I have heard this term tuples. So quite often on the internet, in YouTube and so on, you'll hear people say tuples. I don't think tuple is the right way to call this. Think of the word quintuple. You don't say quintuple. So tuple, so these are tuples, and so with these tuples we can specify how large the dimensions are. So if it's a 2-tuple array, then we are requiring 3 rows and 2 columns, and so it looks like that. So we can fill with ones and zeros, as we've shown here, and we've already looked at this. And another thing we can do with NumPy is create a linearly spaced array. So this statement requires us to, so the tuples, the tuples here, the positions do matter. So the first position is the left value, the right, the second position gives us the right value, and the third position gives us the number of values to use. So if we were to print this out, I'm just commenting those out. If we print this out, our statement is taking 0 as the starting point, 1 as the end point, and using 3 points between, and you can see that there. So if you increase that, then of course you use 5 points and still going from 0 to 1, 0 to 1 using 5 points. So that's how we can create a linearly spaced set of numbers. We can also do that logarithmically instead. So that's the expected result. Of course, here the understanding of these values are different. In the log space, this is 10 to the power 0, which we know is a 1. And then this is 10 to the power 1, which is a 10. So that's the rightmost value there. And we use 5 points between, where that's logarithmically spaced, not linearly spaced anymore. So let's say that was what we have for x. Then if we create an array for y like this, and then if we multiply those two together, we get so, well, of course x doesn't have the right shape, so we need to set this back to 3. If we do this, so x is linearly spaced between 0 and 1, so we talked about this already. For y, it's a 1, 1, 1. So the result is being shown here. This is x times y, and let's just separate these two a bit. And so you can see x times y is being shown here. So obviously this is not the vector matrix multiplication, right? This is a kind of scalar multiplication. We are just multiplying the corresponding the values in the corresponding positions here. So we know x is 0, 0.5, and 1, and then we are multiplying 0 by 1, giving us that, multiplying 0.5 by 1, giving us that, and 1 by 1, giving us that. In fact, let's change this a bit to make it a bit clearer. Let's make y 1, 2, 3, and you can see now 2 times 0.5 gives us the 1, and 3 times 1 gives us the 3. So this is a kind of weird scalar multiplication. It's not really a mathematical multiplication. This kind of result is not any known mathematical multiplication. It's clearly not a dot product, right? In a dot product, we take each column value of x and multiply it by each row value of y, and add all those together. So if we want to do the dot product instead, then we call on NumPy and instruct dot product here, and in that case we get 4, right? So okay, let me just print the value of y here. Print y, and so for the dot product, 0 times 1 plus 0.5 times 2, that's a 1. Plus 1 times 3, which is a 3, so all of that is a 4. So here's the dot product giving us the expected result. Of course, strictly speaking, we should be multiplying x, which is written in this form. It's a row vector, and written in this form y is also a row vector. So strictly speaking, we should be multiplying x by the transpose of y. But I guess that's the kind of shorthand in NumPy. If it detects that these two arrays have the same shape, then it will it's possibly transposing y and then using the operation. So strictly speaking, we should be transposing y. So we can do that here if we write NumPy transpose y. right? So we get the same result. So I would prefer to keep this. So if you're in my course and you mean for this to be transposed, please write it in explicitly. And this is actually a performance hit, right? You are requiring some operations to be carried out, which NumPy doesn't really need to do. But anyway, it makes your code much more consistent with your equations. Anyway, that's linspace and dot producting, and also this weird scalar multiplication. Here you can also extract the dimensions. So if your array looks like this, and so we can create a matrix like this, and here we are creating a row vector, and then we are creating another row vector beneath that. So this is a matrix, and that's the top line of the matrix, and that's the bottom line. And so if we want to know the dimensions of our matrix, then we call on the shape method from the NumPy module, and we apply that to our matrix. And here we expect we do have 2 rows. So the first argument is row, so we get the 2, and we've got 4 columns, so we get the 4. So that's the shape. We can also create the identity matrix. So if we use the I method and we specify 1 argument, so let me just take that off for now. So if we specify I and a number, it's going to assume that we want the identity matrix of magnitude n. So if we say I6, then you can see the 6 ones here and zeros, triangular matrix zeros like that. So it's a diagonalized and ones. So that's the identity matrix. If you want, you can change that. So if you wanted a 6 by 2, let's say, oops. So you can actually do it as a tuple here. So you can get a 6 by 2. So it will work as an identity matrix up to 2 by 2, and then for the remaining 6 rows that we require, it's going to be in the lower triangle space. So it's just going to fill with zeros there. Not too sure why anybody would need to do that, but anyway, that's what you can do. Then another useful one is the reshape. So if you have some matrix that whose dimensions are known, you can then reshape that matrix to any other form. So here, in fact, let's change this to a 4 by 3 matrix. And then we could reshape this. We could make this instead into one long array. So here we created A as this kind of identity matrix with an extra row there. And now we are reshaping it. We are saying, take all the values and make for me a single array with 12 rows and 1 column. So we can see here 12 rows and 1 column. In other words, this is a column vector. So we can reshape our arrays as well. So I'm not really saying matrix, I'm saying array, because generally speaking, let's see, I'm not too sure what would happen here. So in this case, it has accepted more arguments, and although it's not really anyway, so arrays generally are multi-dimensional things, and whereas matrices are specifically 2-dimensional objects. So NumPy is working on arrays. Here we have already talked about this, right? Dot products and transposing things. So, well, here we're looking at the transpose of a matrix. So here we can see, let's say we print this out first. Well, it hasn't spaced it nicely, but anyway, we know the first row is 1, 2, 3, second row 4, 5, 6, and so on. And then if we go ahead and transpose A, we can see it's done the transposing correctly. Then you can reference different parts of your matrix. So we can call on third row and the second column. So the third row is this one, and then the second column is this. So that's the result there, 8. And if we want to pull up the third row and we want all the column values in that third row, we use the colon. So the way we can read this is second row give me, third row give me everything. So we read that colon as everything. So everything in the third row. So you can see 7, 8, 9. That's all there. If you want to reference the last value, not the last, the last value. So you could, if you knew the length of an array, you could specify the last value here. But if you don't know the length of your array, then a quick way to reference that last value is with a -1. So here we are calling up the third row, and then we are referencing the last value in that third row. So there's the third row referencing the last value. That's a 9. That's there. Okay. And we had talked about this already. The random numbers look like this. So random is the class that you call on if you want to generate random numbers in Numpy. And you can have randomly distributed according to the normal distribution, and you specify with size the number of elements that you want to work. Yeah, so you can specify with tuples multi-dimensional arrays of random numbers, and you do have to specify what kind of random distribution you want. So there's also uniform and so on. Uniform and let's see. So you can change the type of random distribution. Then another useful thing you can do is use conditionals. So let's say we created this matrix, this array B, which looks like this. So it's an array going from 1 to 5 using 10 points, which we can see here. And let's say we wanted to create an array of values which were 0 if you were less than or equal to 2. So we want zeros here and we want ones here. So the way we would do that is first to create C. So if we use this, that C will be equal to the values of B being more than 2, then this is going to give us a Boolean result. So if we print that, you can see here false, 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 true, 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 true. So it's false for the first 3 values, right? So our condition is that B must be more than 2. So B is not more than 2 here or here or here, so it's giving us false here. And then it's true, it is more than 2 for the other values, so true, true, true. And that's not quite what we wanted. We wanted zeros and ones. And so the way we can do that is use as type. So we can force a Boolean number to be an integer. And of course, when we do that, it's going to convert a false to a 0 and a true to a 1. So you can see the result there. And so this is quite useful, especially when you are working with discontinuous functions or functions where, or arrays where you want to filter out values, or you want the function to behave differently in different locations. So you can use this useful method. And of course, you can do all this in one statement, right? You can combine these into one statement. Anyway, now those are some of the things you can do in Numpy. Please do have a look at reference guides, and I've tried to show here the operations that you'll likely use most of the time, but obviously it's a large module and there are many, many other things you can do. There is a little bit of the referencing that needs to be fixed up. I'll have to look at that and set out some notes around that. But anyway, I don't want to create the impression this is the only data structure that's available. There are other useful data structures in the Python core. So even without NumPy, in Python core, you also have lists and dictionaries and sets and tuples. Well, we already saw tuples. But anyway, a list, it looks like an array. So you use the square brackets and you specify with a comma your values. But if you want to add more elements here, you can't do that with something like this, right? You can't say, okay, go ahead at position 4, just stick in a 5 for me. Instead, you have to append that to the end of your array. However, once you have created that element, once you've added an element, once you've appended an element to your array, then you can reference that element afterwards. So let's say we wanted to change the value in the second position, which is a 3. Let's say we wanted to change that to a 3.3. Then we can do that. So you can see there's that first result now. 5 has been appended and we've updated the 3 to a 3.3, so that's there. An array is not stuck to one type, right? In NumPy we work on objects will have one type. An array is more a list is more flexible than that. A list can have basically any kind of object. Well, I'm not sure if it allows dictionaries, but anyway, an array can have other types in it. So here we've appended a 5, but we can also append a string here. So to A we've appended a string, so if we print that out you can see the string is part of the list now. And then referencing works the way we expect, right? If we call for the third to the fifth elements, and remember the last one is it's up to and excluding the last reference. So the values there are the third, so it's from 3 to 4. So the third element and the fourth element, so that's what's returned there. So that's a list for you. Then a dictionary, those are key value pairs, and dictionaries are very much like JSON objects. So here are dictionaries, and dictionaries are key value pairs. So you specify, it's like an attribute in an object. You specify a key, and then you specify a value, and you use a colon for that. So here, here's the key, here's the name of the attribute, and then a colon to say what follows is the value for that key, and so there's your value. So to start a dictionary, we use these curly brackets, and here you see we've created a key value of 10, so A1 is 10 and A2 is 12, and you can deeply nest your dictionaries. So A3, for instance, is a key, and this time the value is another dictionary. So you can have dictionaries within dictionaries. So here, A31 is another key in this new dictionary in here. And so you can reference all the attributes in this way. So we've assigned our dictionary to A, and then we can look up the key within A of A1, so that should give us a 10, and then we can look up the key for A3, which is actually a dictionary. So within that dictionary we can look up any of these attributes, and we can see that's going to be a 12. So that's a dictionary, and really those are extremely useful things if you are familiar at all with JSON objects. It really is fantastic, the expressiveness of the code and the ease with which you can transmit objects and receive objects, especially if you work with databases. So dictionaries, don't write them off as this odd little structure in Python. It's really the most convenient way to achieve JSON-like behavior in your code. And in fact, when I first got into Python, that was one of the first things I looked for. How do I make my JSON objects? So dictionaries are in effect the way you can do that. You also have sets. So 2.3 concerns sets. So unordered collections of elements, so bags of things. So if you use curly braces and if you don't specify the entries as key value pairs, right? Here we use the curly braces and we had key value pairs. So if instead we have a comma separated list, then the compiler will interpret this as a list of things. And so that's considered an unordered collection of elements. And you can iterate over this bag of elements with the enumerate method. So if we run a for loop here by enumerating over this bag of things, then we can, if we did it without an index, then we can reference each element of which we are calling bi. If we also want the index, then we would specify two sort of arguments here, and then that would be regarded as the index number, and that would be regarded as in the iteration that's the current selection of element from the bag. So you can see if we run this loop, if we print it out, you can see the element number here and the element itself shown there. This doesn't mean that this is the ith element in the bag, because it's an unordered collection. This I refers more to the iteration number in this loop. So this is considered unordered. Okay, and then the tuple we've already seen, ordered lists of numbers. So this is somewhat like, it's basically a list, but we use this kind of notation instead. And we can reference a tuple like this. So in the same way that we referenced arrays, we can reference elements out of the tuple. But we don't read a tuple as if it's an array. We don't try and use tuples as if they're arrays. And that's because tuples can actually be used as keys in arrays. So we can use tuples to reference it can be used as keys in arrays, or we can use them even as arguments. So we can use a tuple to fill the argument space in a function, and so on. So that's it. Our Numpy module, extremely useful. We can operate quite similarly to MATLAB. So if you're used to working in MATLAB, Numpy is a way to do that. And then we have available to us the other data structures as well. So we can get to our JSON-like behavior using dictionaries.